April 26 Base Camp Titans for Doom. At 9,000 feet, a Denisovan-derived EPAS1 haplotype whispers to your HIF alarm while the thin air refuses to stir. You're chasing Everest while the silence feels like a trap you can't explain, but calm trumps panic when blood thickens. Here are 5 oxygen switches keeping your body breathing down there. Number 1, HIF Thermostat. It whispers, not screams, because the gene keeps the alarm from slamming while oxygen vanishes and blood stays calm. But this calm hides a secret that the next dial will expose. The EPAS1 haplotype that Tibetans inherited from a Denisovan cousin tells the HIF-2 alpha alarm to whisper instead of scream, calming the whole system when oxygen drops. It's a quiet, subtle rebellion. The dial lowers hemoglobin by 6.2 to 12.6 grams per liter. That tiny retreat keeps Sherpas and Tibetans hovering at 14 grams per deciliter even at 4,000 meters without turning sludgy. Despite the allele difference between Tibetans and Han at 78%, this remains the strongest selection signal in the human genome. It explains why the Denisovan signature marched across the plateau in a few thousand years, one of the fastest human adaptations. Sherpas carrying the variant keep SpO2 in the hypoxic range as lowlanders, while their serum EPO stays normal. That proves the gene quiets HIF instead of pumping out new cells like EPAS1. Knockout mice mimic the calm blood response. But the body no longer tries to spill blood to catch oxygen. It trades a bump in concentration for steady delivery. It feels suspicious, yet it keeps pulmonary pressures calm, pregnancy safer, and Everest summits gentler. The same outcome appears in Andes via a different EPAS1 missense mutation. This oxygen economy idea finds multiple routes to the same calm blood. Tibetan Highlanders in Lhasa, Amdo, and Nagku carry the same Denisovan signature, which keeps pregnancy risks low and base camps calmer. Wait until the next dial proves the alarm listens, while the next switch shows the oxygen alarm is not broken but tuned. Number 2, oxygen dial. In Sherpas, the EGLN1 D4E:C127S patch keeps PHD2 active, hydroxylating HIF when oxygen flirts with low numbers so the alarm never slams the make more blood button. Your EPO level stays locked in the Kathmandu baseline, though SpO2 keeps dropping. The adaptive SNPS RS1435166 and RS21536164 ride high, keeping the oxygen sensor set to calm forever while monitoring subtle dips without overreacting. Knock it out in zebrafish and polycythemia ignites, proving this sensor is the pressure point. It works with EPAS1 to craft a gradient instead of a binary panic switch, so the whole response is finely tuned. The D4E:C127S haplotype appears beside the EPAS1 variants, and lab work shows it ramps PHD2 hydroxylation when oxygen dips. Droma et al.'s Sherpa data confirm these carriers hover in the same hypoxic zone as Kathmandu, yet keep EPO calm. Your kidneys stop pouring fuel that thickens. Your blood and balloons your lungs. That quiet buffer gives your lungs a pause so the next drop in oxygen hits without panic. That matters since letting that alarm scream triggers pulmonary hypertension and headaches. Your fuse goes short on every climb. The Sherpas prove this is not elite training. Their genotype keeps that sensor damp across generations, so families can shuttle between Kathmandu and base camp without picking up mountain sickness. When we squeeze the Bajau spleen, this dial keeps the baseline quiet, so the reservoir kicks in when your body needs oxygen. Number 3, Spleen Bank. The Bajau carry a PDE10A allele that lowers enzyme expression in the thyroid and sends T4 upward, quietly inflating the spleen into a hidden oxygen tank that empties when they dive. The spleen stores 160 milliliters of red cells and spits them into the bloodstream on demand. The thyroid spike raises T4 just enough to swell the spleen slowly so rested hematocrit stays normal while the extra cells wait on standby. That boost lifts oxygen content by 2.8 to 9.6% without spamming hematocrit all day. That reservoir exists even in non-diving Bajau, proving it is genetic, not just breath hold practice. In Jaya Bhakti, the allele reaches 37.1% compared to 6.7 in Saluan and 3.0 in Han controls. Neutral simulations peg the divergence at less than 0.001. This allele did not drift and stays rare outside the coast. Researchers documented those frequencies with high-altitude surveys. The organ stays 44 cubic centimeters bigger after correcting for variables. That lets them spend 60% of the workday underwater with 13-minute breath holds and 70-meter dives. Their spleen behaves like an oxygen vault that collapses when the water demands it. UK Biobank data show PDE10A SNP raises RBC counts but not EPO, confirming the reservoir bypasses the usual signal. MP-10 in mice recreates enlarged spleens, proving the gene is causal. The same SNP chips away at hypothyroidism risk, so the endocrine ripple keeps the reservoir ready without hurting resting blood. At this point, your body stops relying on lungs and flips a mechanical switch. Training alone will never replicate that silent tank. Keep that balloon imagery. Next, we relax the pipe so oxygen can flow once it leaves the spleen. Number 4, relax valve. The ACE insertion allele slams a 287 base pair plug into intron 16 so your body pumps less ACE, cutting ANG2 while bradykinin lingers, widening capillaries and letting oxygen flood muscles without the shock of sudden constriction. The allele creeps from 35% in sprinters under 200 meters to 53% in 3 to 5,000 meter specialists. It then climbs to 62% in marathoners and 51.5% in the fastest South African Ironman finishers, compared to 42.2% in local controls. Longer efforts feel less violent when the pipes relax, and interval training studies show carriers improve muscle perfusion and cardiac recovery more than non-carriers. It interacts with training rather than replacing it, so athletes earn the oxygen edge. It behaves like a built-in ACE inhibitor, keeping bradykinin on your side and smoothing delivery. That flow keeps the blood vessels from turning into pressure cookers before the oxygen reaches your mitochondria. That's the calming effect you feel in the final stretch. Your mitochondria have to squeeze the last drop of ATP, so train them like engines. The coastline of this oxygen economy stretches from sensors to engines. When we dive into mitochondria, we know where the oxygen is headed, so we can picture the plan before the pumps fire. If you're finding this interesting, consider subscribing. It keeps research rolling and the weird stuff coming. I drop videos regularly, so you don't have to wait years for the next deep dive. Anyway, back to it. Number 5. Complex 1 tweaks. ND1 and ND2. Complex 1 subunits on the proton pumping axis. They are swapped in Tibetans and Indians, so leakage drops. ROS is limited, and each oxygen molecule stretches into more ATP. Highland Tibetans carry the M90101C1b haplogroup with ND1T3394C. Lowlanders hover at 1.7%, while Highlanders hit 25.3% up high. COX2G7697A mirrors that jump, translating to an odds ratio near 23.7. It keeps rising with altitude. The same ND1 residue pops up repeatedly on different macrohaplogroup M backgrounds and in high-altitude primates and yaks. This hotspot is where nature tweaks the engine. Cryo-EM places these residues over the hydrophilic axis. Perret et al.'s Cryo-EM map shows mutated side chains hugging the proton-loading sites. One swap tilts the water wires that shuttle protons, so leakage drops and every oxygen earns more ATP. A shift alters how the enzyme staffs its proton-loading sites so that each NADH pushes 4 protons without wasting molecules on leakiness. Tibetans manage these tweaks with fewer mitochondria but more efficient ones, while the Andes bring their own ND2-centric patterns alongside vascular changes. This means oxygen stress gets resolved across continents by pipes and engines. That is the payoff. From sensors to spleens to vessels to mitochondria, the oxygen economy rewires where it hurts most. Field surveys across Tibetan Andes confirm these genetic footprints, while remote villages and research cohorts report the same markers. Quick reminder, if you're enjoying this, subscribing still helps out. Now, where were we? Thanks for watching. If you enjoyed this, subscribe and hit the bell so you don't miss the next one. See you